Hi, folks. Welcome if you are coming back here after a long hiatus for me not doing the live coding session. I'm back here now, and thank you. I hope my music isn't too loud. Sometimes it's hard to tell, right? So I don't know if you have actually joined my podcast. I started doing so, right, and it's on my same channel because Manny, my podcast co-host, he doesn't have an account. So in order to set things up quickly, because I already have some things set up, although doing multi-streaming has always been a challenge. And in my case too, and I, as you can tell, like we had some issue, right, with the delay at the very first episode. So I was hoping, if you're a returning person, if you have subscribed to me, thank you very much, and have confidence in us. And we want to do some more bringing out like AI, and also too because Manny has worked with. He also started off with Java, so both of us are Java champions. And interestingly, too, 4 years ago or so, he said he started working more with machine learning, got interested in that artificial intelligence. So, and and even now today too, I have started doing AI stuff, right? And not like I don't abandon my Java stuff. I continue doing whatever it is, even though machine learning, AI are primarily driven by Python. But the thing is too with Manny is that he wanted to get into it more, and he's been working with it for a while, building apps too as a consultant. So he brings a lot of the life kind of real life, I suppose, like production system building to him. So it's been great for me, because I have to admit too, I started working more with AI machine learning. That was back when I was at IBM. It was like 2019, and I actually did a talk. Back then it was event streaming, but back then there wasn't any generative AI or chat GPT. So then I was mostly, we were working with streaming with our socket, right? If you are, if you're a developer, you may be aware of it. It's basically with reactive streams. So that's what I work with, and then with my co-speaker from Ukraine, Oleg. So we work on that, and we did a reinforcement learning, machine learning techniques to build what you call it, oh my gosh, Pac-Man, right? Pac-Man game. So that time too, it was more the traditional AI stuff, and that's what we worked on. And these days too, it's like essentially almost I'd say 2 years ago or a year and a half or so ago, right, at my previous company at DataStax, and that's when they wanted to add in vector database and similarity searches to their Cassandra database. So that's how I got into working with generative AI. And it's something that I actually enjoy quite a bit too. And the reason is that I realized too with AI, especially if you want to get into the nitty gritty, right? All of these details, the algorithms, the training the model, there are lots of math algorithms that go into it too. So that's my background, right? If you've been following me, you may be aware I was a math and computer science major. So I do have to say too, working in the computer field, it sometimes too is kind of dull. Sorry to say that, but dull in the sense that, what we learn from school, we're like building new things, being creative. But when you work out for an IT company, or even just a company that has an IT department, a lot of times these systems already been built. And sometimes too, they could have a mix of different kinds of technology, and kind of unfortunate that sometimes these technology may not be the most exciting. And so you go into this IT department, and then you'll have to fix issues, and they may not be well designed and got issues. I'm sure some of you who are in the field are familiar with this kind of phenomenon, right? But that's okay. That's just part of how work is, and it's not how it's kind of being, so to speak, right? When you go to school, it's like glorified, building new things. But anyway, going back to the Gen AI and machine learning stuff, I was actually happy because all of a sudden I realized that my math skills, are kind of being put into use, trying to understand how vector database works, how similarity searches work. Is a lot of linear algebra involved. So anyway, that's how I got in. But the thing is too, is that I feel, right, if we are developers, if we want to be doing programming, essentially, it is an exciting thing. I mean, let's look at it that way, right? Yes, people are worried about AI taking our jobs. I really don't think so. I mean, the current ChatGPT might look amazing, but think about it. It is actually mostly doing kind of one-shot deal, right? It's essentially, I want something to be done, tell it exactly how you want it to be done, or write a poem, generate, as your code, some specific task, and then tell it to do, and it does a great job. But it's actually not built to be able to handle complex workflow. Let's say if you kind of need to make, an airline reservation, you need to go through many things, right? You need to search, look at all the options you have. How do you build a route? Sometimes it may not be as easy as, say, for example, I'm in Chicago. It's easier in a major hub, right? I can fly anywhere, direct flight. But let's say I live out, somewhere in northern Minnesota, and I would have to drive down. Maybe from those people, they have to drive to the Twin Cities, right? The Minneapolis, St. Paul area, and they have to drive down there and then find another flight, and then those flight may not be direct. But actually, I think Minneapolis does have some direct flights international, which isn't bad. But let's say too, even like some very rural area, right, like countryside or something, and then you have to like hop on it, maybe find the nearest small tiny airport, fly to another kind of mid-sized hub, and then from mid-sized hub you go to a big hub like Chicago. So it's just a lot of like hops to, so to speak, right? And then how did I get into talking about this? But basically what I'm saying is that, okay, flight reservation. So if you need a robot to help you plan that, it goes through so many steps. Not only that, you need to price it, right? You need to interact with some price systems. And then also too, if you need to do credit card, it needs to then interact with your payment provider to behind the scenes. Of course, it will work with, the banks that are operating all of these credit card services, all these small steps. And then you need to set up like notification, you need to set up a lot of things. So all those too, how the whole sequence of things needs to happen. Now the thing is too, there are lots of kind of like efforts now in doing, using agents, right? These are agents kind of help with, it's almost mimicking human beings collaboration type of activity. So we can kind of think of breaking down a task into many subtasks. But still, you have all these small agents doing different things, then you need a project manager, so to speak, agent to kind of tie everything together. Much like if you think of an orchestra playing some orchestral music, symphony, you need an conductor to make sure that all of the parts are playing their parts at the right time, so the music will come out correct. So that, likewise, what I'm trying to say is that you will need some ways of kind of making these generative AI to work on such a high level. There's still some ways to go. And don't forget too, with generative AI, it's all fuzzy logic, right? It's not deterministic, the kind of logic behind the scenes. So as a result too, that sometimes if you kind of you use that, it could come back, you ask a large language model one question, it comes back with some answer. And then the thing is too is that you ask it again, it may come back with an answer that's slightly different. And that's because of the non-deterministic type of behavior of these language models too. So all of these two kind of make generative AI not quite ready for prime time. However, it has its place, within the computing world. It can do maybe painting a picture, putting together images, producing a video. All these things are good. Writing a blog post. But anything beyond that is a little bit kind of iffy, not very stable. But so my thing is that today, right, I was thinking it would be good to kind of do some coding. I haven't kind of actually do coding for a long time. And I finally get to actually do some code, the past few days, because I did not have any travel to do. So then I actually sat down and said, okay, I better start coding. Part of it too, you may be saying, yeah, I go and do presentation, but sometimes presentation doesn't have to be exactly showing a lot of code. So as a result, I don't get to write as much code, but I would like to do it. So anyway, so for today, how about this? I'll show you something. And this time, as you know, there are vector database, right, to handle. Actually, you know what I'll do first? Let me kind of quickly, assuming not everybody is familiar with this. So let me kind of introduce a bit of vector database, and then kind of, again, very fast too, not going to be spending like way too much time on this, but I'll just quickly show you. Okay. And let me then switch to another mode too, because right now I'm taking up too much of the space. So let me kind of switch myself small, and then I will bring myself out here with this slide that I've done this a few times too. So wait a minute, and where am I? And I think I may not be in the right place, but let me do this one thing. I wanted to, well, first of all, folks, this thing, I think it kind of explains too. I like to use these things, especially for new folks who may be new to this stream. Just wanted to show you that, okay, this is AI, and we are, the machine learning, and generative AI is what kind of the ChatGPT thing is doing, and relying heavily on the LLMs. These are large language models, and as such, that's what drives things, right? Think of it, we call it, technical terms, it's like the runtime, of a ChatGPT. It gives it is processing capability. So that's where it is, and it leverages heavily on natural language processing. That's why you can talk to it like talking to another person, right, to the robot. And there are also like deep learning that's involved, all of the neural networks, all of these things. So that's where the data is. So data is very, very important part of, generative AI. So I just wanted to kind of get in. It's basically the, let me see, the vector database, So what is vector database? It's basically a purpose-built database, right, that serves up vector data type for complex machine learning purposes. So how it kind of can work, again, that brings in all the mathematics behind the scenes. It's all these linear algebra that enables it to do searches. But first, we do need to, any kind of data comes in will need to be converted to embeddings, right? So embeddings is what I'm going to show you. And actually, this code too, I will show you without using any special sophisticated model. Let's kind of generate our own embedding, and how would we do it? So I'm going to show you that. And essentially, too, it makes use of some approximate nearest neighbor type of techniques, or it's called ANN, right? To do these techniques is leveraging on the math. Now, here comes the math. Is all the, if you're familiar with like matrix mathematics, and that's where it comes from. So, folks, if you're interested in math, go kind of look up, I guess Khan's Academy, too, has all the kind of information on, math algorithms, all of these things, and it has good explanation of matrix math if you're interested. So essentially, too, like in a two-dimensional, and essentially, right, these vector embeddings can be stored in multi-dimensional format. Think of a dimension as like, in this example, I'm going to give you like movie recommendations. So if you need to store the movie, a movie contains many properties to it, right? The name, the title, the genre of the type of movie it is, how long it is, all of these things, right? So these are being kind of stored as dimensions of, about the movie. So anyway, in this particular very simplified case in here is that I have only like two-dimensional data. So that's very simplified, like a hello world. So you could end it up, right? If you kind of look at it like, like a plane, right? You're looking at your data. Your data can be stored as V1, V2, and V3. So they occupy different space in this, vector space, so to speak. And so when you go to search for it, and that's where all the map comes in. Let's say I want to search for, a string that's actually represented now called V1 after has been converted to embeddings. Then basically V2 and V3 are there, in that space. Then basically the math will enable you to look for the data that's closest to V1. So in this case, V2 is closer to V1 than it is for V3. So that's the idea. So okay, so this is pretty much it. And then I just wanted to quickly show you, there are many open source vector databases, so you can just pick up one and start running with it essentially. But I say, from what I've heard so far for open source, Milvus is one of the better ones that a lot of people like in terms of being kind of robust and easy to pick up. Although I do have to say PgVector, which is what I'm going to work with, also is actually quite easy to work with too. And it's not as difficult. It's an extension of Postgres. So if you're familiar with that. And there's also one called Chroma, is also open source. And then Fast is from Meta or Facebook. And then Quadrant 2 is actually I believe they are Go or Dart, or one of the two, written in that, also super fast too, and Wi-Fi 8. So, all right. So these are the things. So let me then kind of switch back, okay? Let me switch back over here, and then let me then, okay, no. Actually, you know what? I need to move this out of the plate, out of the way. So let me move it back to over there. Okay, so, and by the way, this is the Cincinnati Bridge, because my company, Calibrity, is based in Cincinnati. So, and I took a picture of it too. So just thought I'd show you. Now, the thing is too, let me then get back to my thing so I can move it over. Okay, here. So this is the code, right, that I wanted to show you. It's called movie recommendation system in here. And of course, I've already put together that, but let me kind of step through and go through with it with you. But give me a second too. I'm like not finding things on my screen, so please bear with me for a second. Let me kind of locate my my thing. Yeah, I actually cannot find this screen that all right. Oh, actually, you know what? I need to do this one thing. I can't just move it. I think I have to do this. Okay, and then move it back. Okay, no wonder. All right, yeah, okay. All right, cool. All right, then. I just want to make sure, too, you can see it okay, right? And here we go. Let me kind of move things over there. And let me also actually check, too. Manny is supposed to want to talk with me. So in some ways, I wanted to talk to him tomorrow, but then he said he's busy. But we actually are preparing for another podcast for next week. Yeah. Okay. So I think what I'll do is let me quickly show that to you. And again, this turns out to be a small, short, broadcast for now, because that's the problem, is that he can only talk for the next 15 or in 5 minutes for the next 15 minutes. I'm just like too busy these days. So, but I do want to, let me not waste time, and I will just quickly show you what this is, right? So I call it a movie recommender in here. So recommendation for that. And somehow what is going on? I think my green screen is not working too good. So let me kind of fix that. And okay, ooh, actually, you know why? Because of that. Okay, all right, that's good. All right, let me kind of quickly show you. And I do need to make this a little bit. Okay, let me do that. Okay, let me increase the size a little more. Okay, I think this is a little better now. Okay, so let me quickly show you. So for Java, so this is what we're looking at, and okay, okay, I think we're good, right? Okay, so get rid of this, and let's take a look at this, right? Let me make it a little bigger too. Wait. I guess I used to be able to use my keys to increase the font size, but I think it's okay. So here we go. So movie recommendation system. I hope you can see it okay. Maybe I'll still make it a slightly bigger, because I feel that it's a little bit small. Maybe slightly more. Okay, yeah, okay, that's better now. So as you can see, right? So right now too, first, what you need is a Postgres database on your local system. And no need to actually create the database, because my code already takes care of, if you don't already have the database, which I happen to be calling MovieDB, I will create it for you too. And then these are just different, password and all of these things too. And, that's fine. I mean, it's local on mine, so it doesn't matter. Okay, so now on my main, I actually have created a couple methods, and I create the PgVector extension. Now, first of all, in order to use this, you do need to install PgVector. So what I did was I actually go and use Brew, because I run on Mac. So then I use Brew and install PgVector. So that's what I did. And you can kind of search for it. It's fairly straightforward. Make sure you also have Postgres, and I'm using version 17 right now. And for Java, I'm using Java 23, just so you know. And I'm using the Adapt Open JDK 23. But it doesn't matter. It can be any version, should work. And then I also have a reset movie table method, then that will just reset things, and then meaning clear up all my tables and everything. And then the next thing I do is I do a create movie table and then insert the sample movies. Now, again, this is very manual right now. In reality, too, what I might want to do is to load up, a set of movie titles, all of these things in. But for now, simplicity rules. So for the very first version, and then I'll insert, and then what I'll do is I also update the movie with the embeddings. So, and then from there, I'll just do a query. Now, in this case, because I only insert 2 rows, then I basically said the query movie is Inception, and I want to find similar movies. So over there, to find similar movies is where I do my search of the movie, and then I'll print it out what I can find. That's a similarity search. Okay. Let's then first look at create PgVector extension. That's something we need to do. When you kind of install PgVector, it becomes an extension to Postgres. All you need to do, a SQL command, is create extension if not exists vector, right? And that's the thing to use. And all I'm doing in here is that I have a couple of static methods to kind of do the job, right? And that's what it is. So create PgVector extension first. And all I'm doing is just using my driver manager and then do the connection to Postgres, and then essentially then create my extension. And then I create my table. This is where I do it, right? Create table, essentially just SQL, right? I just do, create table if not exists the movie. And all I have right now is an ID for the movie, and then also a title and the description, and essentially the embedding. Now, again, these are just some, kind of like a fake thing. In reality, right, these embeddings could be, again, could be the length of the movie, what language it is in, all these kind of things about the movie, right? Is it black and white, is it color, whatever, right? So those are vector. But right now, for demonstration purpose, I create an embedding field using this embedding type, and then essentially set a 100 dimensions, 100 elements dimension of this vector. And then what I do, I execute it. And then the next thing is I do a reset movie table. I want to make sure that I drop the table if not exists, because again, this is for demo purpose. I just go and kind of do that. And all I'm just doing is drop table if exists movies. And then now I insert the sample movies. As I mentioned, I only insert 2 rows. Again, very hard coded. I inserted, essentially to I prepare statement, I insert into movies, the title and the description, and these values first, right? So I populate with Inception. It's basically description, a thief who enters the dreams of others to steal secrets from the subconscious. The other is the Matrix. A computer programmer discovers the shocking truth about his simulated reality. Okay, so this is simple enough. Now I go and actually update the movie embeddings too. So this is where I do it. Do a select statement from the movies, and then update the movies and set the embedding, accordingly. And then also where the ID is, blah, blah, blah. So all I'm doing, the same boilerplate, doing all the driver, manager, the statement preparation, all these things. And then now I go and basically just insert the data, right? And I insert them essentially to the description, and then I generate the embedding. See, this is the part, right? I basically will call a method called generate embedding, and then I pass in the description. And this is where I will convert these embeddings into a floating point array, or an array of floating point numbers. And over here too, now, don't worry about all the details now, but I essentially do need to convert it back to a floating point object array. And then from there, then I can set the array, right? Essentially, I call it, the vector type. I will have to call the prepare statement set array and pass in this array. This array is basically the floating point object, right? Of the embeddings. And then I basically then set this ID and then execute the update. And that's how I update my embeddings. And then the next thing, this particular generate embedding is also the crux of it, is where I actually use an open NLP simple tokenizer to actually tokenize these values. So as you can see, I pass in that description. Now above too, what I do is I generate embedding, passing in the description. So those are kind of description of the movie. I basically pass them in. And what I do is then I use the simple tokenizer and use the method tokenize to basically convert, first of all, the strings into lowercase. And then each token too, I broke it up, right? Tokenizer, and then broke up into tokenizer, and then basically then tokenize it. And then that will return me an array of string tokens. And from there, I do need to convert them too, and into like different floats, and then I also call the random to basically convert it to, and that's how it happens. Okay, so then now when I go and query it, and that's where I do it, I select the title from the movies where title is certain ones, and then I order it by the embeddings, and then I also limit 5 in this case. So as you can see, that's the crux of it, right? So okay, so I think my friend Manny is waiting for me, but I want to thank you very much for having sat through, and I appreciate your patience with me. This, again, is a very short 30-minute video. So next one, what I'll do is I'm going to use a sophisticated model using an OpenAI, for example, OpenAI, or use one of those that are publicly available sophisticated model to handle the embedding part. But it's at least with this very simple way, you can see how embeddings get kind of generated too, all the conversions that are in there too. All right, so thank you very much. I hope it is helpful for you, and I will be coming back, okay? And next time. All right, take care, everybody.